So first of all, good afternoon, everyone. Today I am Aman Srivastav and my fellow colleague Sanskriti Tiwari are welcome you here in our knowledge session, in which we are going to present on the topic AutoML in Vertex AI for Mlops. But before we start our knowledge, please let's follow some knowledge etiquettes. Please be prior 5 minutes before joining any knowledge session, and please make sure you give a proper feedback to a person whosoever gives the knowledge. It is so meaningful to us. And please, I request you to keep your phones on silent mode to avoid any disturbance. Moving forward in agendas, we will cover like what is Vertex AI. In that, we will discuss features of Vertex AI, orchestration of Vertex AI, and again that we will talk about what is AutoML in Vertex AI, traditional versus automation. That then we will discuss about workflow in AutoML, challenges in AutoML, foundation models of Vertex AI, and model evaluation, and then finally we will move to the demo part. So moving forward, let's first discuss what is Vertex AI. Vertex AI is basically a machine learning platform that was provided by Google on 9 June in 2021. It was created by Google to ease the development process of any ML model so we can ease our work and create a productive solution. As well as it provides us a collaborative work. So if we want to work with our team along with the working on a proper solution and want to achieve some goal, we can work together as a team on this cloud platform, and where we can put our efforts together. Since it also offers us some unified interfaces where we want to use some libraries or some frameworks like PyTorch, TensorFlow, and scikit-learn. So we do not have to worry about how we are going to do that. The Vertex AI also gave us some instances of these frameworks and many more. So we just have to create a particular instance and then we can utilize it there. Once we have done with our model creation part, then it has the feature of our deployment. So in that we can use the technology like Docker containerization, in which we encapsulate our whole ML model or its dependencies and its libraries together. Then we can deploy our model. So once our model is deployed on the cloud, we can do such activities like online prediction and the batch prediction. In online prediction, we can send our instances as an input and get the result as a prediction in the real time. While we talk about the batch prediction, in batch prediction, instead of just sending a single instances of the inputs, we can send bunches of our inputs and then get the whole output as a result by using this option of the batch prediction. Since it also provides us some pre-built models, like we discuss about image and language processing that contains many more fields into that. So we will discuss about that in brief in later slides. Whether we want to integrate some of our model, like we have created our model and it is globally available. So now it's time when you want to integrate a particular model in your application. It also supports us the API integration feature where you can use any different programming language like Python, Java, or React, or any environment like Ruby, Rails, Node.js, depending upon that. So you can also use that. Moving forward, let's discuss about features of Vertex AI. So it offers us AutoML, where AutoML eases our work by automating most of our tasks of creating an ML model, where we involve activities like hyperparameter engineering, model creation, and the evaluation. And moving forward, we have custom training. Suppose we want to create a solution that it doesn't have, and we have some problem that it is specific to a particular problem, and we want to create a solution for that. So you just have to write your own code using this custom training option. You can write your own block and you can containerize that particular block of your code and deploy your ML models there. Once you have done again your training part, so you get the option of storing your models in the model registry, where we get to switch between the versions, like which version is performing best. If we want to monitor between them, we can switch between them. We want a particular central repository to manage our all models that we have created, and then we deploy a model. Once our model is deployed, we get an endpoint, and that endpoint represents the interface where we can do our prediction and get the results by integrating it. And after that, when your model is working, you also get the configuration options like we have mentioned here, like scaling, machine type, containerization option, request response format. In scaling, we get to control or configure how many instances we want to handle of our MM model, or what traffic split we want to do there. In machine type, we can configure of what kind of virtual hardware we want to utilize that our model requires according to our needs. In containerization option, suppose you have used some particular dependency that is required by your ML model, so you can containerize those dependencies in your ML model, and you can use it there. In request response format, we get to choose what kind of format we want as an input, like CSV, Excel, textual data, or the JSON format. That kind of things we can configure in the Vertex AI and go ahead all on the pipeline of the handling those particular workflow. So moving forward, let's talk about what is orchestration of Vertex AI. First, let's know what is orchestration. Orchestration is basically all the steps that are automated of the coordination and management of a complex tasks that are interrelated to each other from the very first step to the last until you build a proper solution. That all the steps are considered as the orchestration of your Vertex or any workflow. Like I have mentioned here, we have the steps like extraction of the data, validation of the data, and the preparation of the data. Then we train our model, then we evaluate on that particular model, then we validate is on that model, and then we finally deploy that model. So let's discuss those points. In data extraction, we get the relevant information from our data, that our data is correct or not, it is relevant to our output or not, so it won't cause any improper direction to our result. Then we organize it there. In the validation of data, we ensure the quality of the data. So suppose if you want to build a solution, the data quality matters so much. A poor quality of data will not give you a proper result. So we ensure that in the validation phase. In the preparation of the data, whenever we create an ML model, we do the pre-processing and the transformation of the data and the feature selection. There are further things we do before going into the training phase. In the training model, so a person invests most of the time in using the algorithms and spend more trials on that. So in Vertex AI, we can automate that particular thing instead of worrying about the technical efforts. We just have the option of using it. In the evaluate model, we evaluate the performance of a model. In evaluation, we get the matrices like precision and the recall and the confusion matrix that we will discuss how that particular thing works. So moving forward, we have the validation model, a validate model. In validate model, we validate our model in terms of the accuracy. Suppose we have created a model, it is giving us accuracy around 85 to 90, and we want to increase our accuracy of a model. So we again get back to the training part. Then we again do some tuning in that particular model. We change some parameters and change some input. We redefine our matrices, then again train our model, then we again evaluate what kind of accuracy it is giving in comparison to the last one. And then finally, we deploy a model. That model is representing as an endpoint that is globally available to the servers. So moving forward, let's know what is AutoML in Vertex AI. As we have already gone through our overview, well, AutoML basically it eases our work. Suppose we want to build a solution, but we want the result to be more productive instead of just working on creating a solution on ours and spending much of time in the technical things, maintaining the infrastructure. So here AutoML comes in the picture where it eases our most of the task by automating most of them. We can get the option, we have the option of interacting with the AutoML, we can use the UI based or the custom coding based, whatever we feel like to use according to our need. In other hand, it has the pre-built models. In that, it has a model garden where it provides some pre-built models. We do not have to create our model from the scratch. Like we will discuss what kind of models it has. We just simply have to integrate that particular model in our application. While whenever we want to create a solution using an AutoML, it provides us some sections like I have mentioned here: image section, tabular section, text section, and the video section. Like this, in the image section, we get the option of a single label image and the multi-label image, where we get to identify between the single label class or the multi-label class. In the object detection, we can create a model of identifying the objects either in the picture or the video. In the segmentation, we can identify between the classes of the image which class that particular image belongs to. In the tabular section, we can create a models of regression and the forecasting in regression. We can create models of the classification. In the forecasting section, we can create models of the weather prediction or the stock price prediction. In the text section, we have the options of single label text and multi-label, where we have the other option of entity extraction, where we want to extract some information or the some meaningful thing that represents in a texture that cannot be easily visualized by a human. And then here I have a sentiment analysis, like we can create the model of finding out the sentiments behind the particular message. Like if we discuss, Twitter has already created one of its application using their ML model, where they identify from a person's post what are the intentions behind it. Like that kind of model we can create using the AutoML. In the video section, we have the action recognition. We can create a machine learning model of like if you want to identify or create an application of the yoga a person is posing particularly proper or not. We can create a model of video classification. Suppose you have two categories of videos or any other categories that you take into account, and you want to classify what class that particular video belongs. It is entertainment, or it is a knowledge based class, or it is just some serious content. So that kind of models we can create using this section. In the object tracking, we can take the example of tracking between the civilians and the vehicles in the live footage. That was all the options that are provided by the AutoML. So moving forward, let's discuss what is traditional versus automation. First, know what is traditional. In the traditional method of creating an ML model, what we used to do, we used to gather our data from the different various sources. And it was a much of a hectic task, because we have to maintain an infrastructure to store that particular data. Once you store the particular data, you have to organize it, redefine it, and then you have to do the validation of the data. You have to find the correct data. You have to remove the ambiguous data into that. That also takes much of a time. Then you go into the we go into the phase of feature engineering. In feature engineering, where we select our important feature that are playing an important role in creating our model. We identify which feature is most important, which is playing a less important role. We exclude some features which are creating the noise in that data set, so we want to exclude that particular feature. Then we final phase of the training and the validation model. In training, we identify which algorithms is working on our data set properly. Is it getting the particular output that is satisfactory to us or not, that it will work properly or not. Then we again go and again do the trials onto that by using the different algorithms, different matrices, by tuning it again and again. That also takes much of time. Then we go into the production phase. Once our product is deployed, we have to gather the feedback from the market, that how our model is performing in the real time. And we evaluate the performance of a model. Then we again get back to the training part. So that was all the process of traditional way, where we used to do the creation of RMM model using this way. When the AutoML comes, it reduces much of our human efforts by the data collection process, where we do not have to worry about the infrastructure. We just have to store our data, where we have the option of the data buckets. So you can store your various data using that particular feature. In the validation of the data, you simply upload your data, you validate the quality of your data using the AutoML. And then again, you go into the feature engineering part, where we do not have to worry about what feature is important, what we have to exclude. We do not have to handle the null values. The Vertex AI automatically will handle all of that processes for us, which is AI powered. And then we go into the training and the validation models. So we do not have to again worry about the algorithms and the matrices. The Vertex AI will identify according to it, and it will apply it what is suitable for our problem. So then we can get the proper solution. Once our model is created, we go into the production phase. Where we create, develop or deploy our model. Once our model is deployed, we can access it globally and integrate in an application, while it gives us the live support of the monitoring. So whenever a person is interacting with our ML model and doing the real-time prediction, getting the results, we can monitor how it is performing by using is the live monitoring feature. So this was all the processes of the automation where it was powered by the AI using its AutoML. So moving forward, let's talk about workflow in AutoML. In workflow in AutoML, we have already discussed the overview from the top, like the basic major executions that we do in creation of a model, like the data readiness, feature engineering, and the parameter tuning, where it has some background processes also, like the data labeling, as we can see here, and the feature store, where we want to store our features, so we do not have to compute it again, which feature is important. So features are stored in a application. We can switch between the data sets where we do all the experiments again and again. So these are all the background processes that we consider into the workflow of it. Once we are done with that part, we go into the model serving, where we serve our model to the users. We understand what kind of tuning it requires, where we do the prediction on our model and evaluate how well it is predicting the output. Then our model is finally deployed. We monitor, like we have already discussed about this, we can get the live result of our monitor, how well model are performing in the real world and how well it is giving the response to the users. So we can switch between our models. Suppose if we consider that our particularly different models that we want to switch between, then we can do that using model management, where we also store the information about the data that we are interacting, that particular model is interacting with, where the metadata comes, and we have the continuous monitoring process. So these were all the behind process that are taken into an account of creating a particular pipeline, and that are considered as the orchestration whenever you build a ML machine learning solution. So moving forward, from now here on, my fellow colleague Sanskriti will take on. So let's Sanskriti.
So thanks, Aman. Now moving on with our next topic, that is challenges in AutoML. So we'll go to the next slide. It's actually, it's okay. Now, while AutoML enables non-expert to also implement ML modeling, on the other hand, it does have some challenges as well. So let's discuss those. The first one that we have here is data preparation. Now, this involves transforming and processing raw data into a suitable format that can be used by machine learning models. So most of the time is spent on thinking and understanding the problem statement and pre-processing it, trying different approach on our data so that am I audible now?
Yeah.
Okay. Yes. So most of the time is spent on thinking and understanding the problem statement, pre-processing it, and analyzing the approaches. So this process cannot be automated, and thus becomes a very big challenge in AutoML. The next point that we have is training time. Now, this training time refers to the time duration required to train a machine learning model on a given data set. Now, while using AutoML, model training process does take a lot of time. So, some of the aspects that can be are that the data set is very large or the model is very complex, and there can be many more. So, this is a significant challenge in AutoML due to its impact on efficiency and scalability, and thus also become a very big challenge. The next point that we have is lack of control. Now, this refers to the limited control and visibility that we have in the underlying process of AutoML or the decision made by AutoML system. Some of the aspects that we have here are model selection, hyperparameter tuning, feature selection that we don't know a lot about. These are the underlying process that happens in model training, and we do not have a lot of visibility about these, thus have a lot lack of control. The next point that we have here is overfitting. Now, before knowing it as a challenge, the first thing that we should know about is what is overfitting. Overfitting is a condition when our model performs well in training data but does not perform well in testing data. In AutoML, overfitting can be particularly problematic because the process of model selection and hyperparameter optimization is automated. We do not know about the underlying process that is happening in model training, making it easier to accidentally create overfit models that can be complicated and decrease our accuracy, thus also become a very big challenge. The next point that we have here is optimal resource utilization. Now, this involves efficiently allocating computational resources such as time, memory, and pre-processing power, since the bill can quickly go up whether you're on-prem with expensive GPUs. As AutoML involves training and evaluating multiple models with various configuration, the efficient use of resources become crucial to minimize the overall computational cost and end time and the time required. So these all were the challenges that we face in use while using AutoML or might face using AutoML. Although we have a lot of challenges, we do have a lot of benefits in AutoML as well. So moving on with our next slide, we'll discuss one of the benefits that we have in AutoML. Foundation models of Vertex AI that is provided. Moving on to the next slide. Yes. Okay. Vertex AI provides us pre-trained multitask models that can be further tuned or customized for specific tasks. Now, the first one that we have here is Palm API for text. This model is fine-tuned to follow natural language processing instruction and is suitable for a variety of language tasks such as text classification, extraction, summarization, and content generation. Text Bison is the name of the Palm API for text large language model. Now, the Palm API for text is ideal for tasks that can be completed with one API response without the need for continuous conversation. So, for text tasks that require back and forth interaction, you can use Palm API. For example, if we want to summarize a chapter from a textbook or describe a product description that is very large, you can use Palm Text API to shorten or summarize the text. The next model that we have here is embedding for text. Text embedding is a NLP technique that converts textual data into numerical vectors that can be described by machine learning algorithm, especially large models. These vector representations are designed to capture the meaning and content of the word. Some of the use cases are semantic search, text classification, clustering. Now, in text classification, we want to classify whether a review is good or not. So, in such kind of problem statement, you can use embedding for text foundation model to have your desired output. The next model that we have here is label detector. Now, a label detector classifies images based on labels and calculate the probability of each label presence in the image. Users can use the label detector to determine whether certain object or thing are likely or unlikely to be present in the image. The next point that we have here is BERT. The full form of BERT is bidirectional encoder representational from transformers. It provides dense vector representation for natural language by using pre-trained neural network with transformer architecture. Also, neural network-based technique use it to train your own question answering system, and there are many more problem statement you can solve with this. One of the use cases that we can have is take token prediction that predicts any word in the next input. So moving on with our next topic we have here is model evaluation. Model evaluation is the process of assessing the performance and effectiveness of a machine learning model about how well our model is performing on our test data. The first one that we have here is a confusion matrix. A confusion matrix is a table that visualizes the performance of a classification model by summarizing the prediction made on the dataset up against the actual labels or actual class labels. As we have here on the right side are the confusion matrix. There are key points such as TN, FP, FN, TP in the confusion matrix that we should know about. So TP is true positive, which is evaluated as predicted true and actual true. Tn is true negative, which is evaluated as predicted false and actual false. Fp is false positive, which can be evaluated as predicted false and actual true. And Fn is predicted false and actual true. So the use of all these will be discussed in the further slides. Now here we have a model evaluation on the basis of classification and regression model. The first one that we have here is accuracy. Now it represents the proportion of correct prediction made by the model out of the total number of predictions, which can be calculated by true positive plus true negative divided by the total predictions made. The next one that we have here is precision. Of all the instances the model predicted as positive, how many were actually positive? So let us suppose we have the model predicted 10 as positive, but there were only 5 that were actually positive, so that becomes 50% of the precision. The next one that we have is recall. Now of all the actual positive instances, how many did the model correctly identify as positive, which can be calculated as the ratio of true positive out of everything positive. The next evaluation matrix that we have is F1 score in classification problem. F1 score is a metric that combines both precision and recall to provide a balanced measure of a classification model, and which we calculated as the harmonic mean of precision and recall. The next evaluation matrix that we have here is a regression model, which consists of mean squared error, root mean square error, mean absolute error, and R square error. Now, mean square error is the square of the difference in the original values and the predicted and predictor of predicted observations. Root mean square error is the major error in model prediction and also provides an estimation of how well your model is predicting on the target or the original value. Means absolute error is the average of the difference between our original values and the predicted values that are or the observation of our data set. And R square measures how well the data fit the model or can be said as the goodness of the fit. So these were the model evaluation metric basis on the classification and regression model. Moving on with the next slide, which is our demo. So in our demo, we have taken an example of credit card defaulter, whether there are defaulters or not. So we'll provide a data set to, we'll create a data set in Vertex AI and apply AutoML on it. And we'll show you what is the accuracy of our model basis on how many there are there in, how many in our data set are defaulters or non-defaulters. So from here, Aman will be moving forward with our demo.
Thanks so much, Sanskriti, for explaining so nicely. So continuing with the demo, let's quickly move to it. So this is basically a Vertex AI UI, where we can see like the points we have discussed about the pipelines and the feature store, data sets, labeling tasks, training, experiments, metadata, model registry. All the features are presented over here. Like we talked about the pre-bid models that are available in the model garden. So if you go into that and try some of the models that Sanskriti has discussed, like the PAM API. So you can see all of the models are presented here. You can use that in your application as per your need. So let's move into our example. So now first step is to create our data sets like we have discussed. So we will just simply, this is the basic UI of how we create a data set. Just click on create. Now we get to choose what kind of problem we want to build for. We want to build a solution. So let's first name our problem. We want to create a data set for credit card defaulter. Like you can see, we have the options like I have mentioned: image, tabular, text, and the videos. Since we have the classification problem of whether want to identify a person is the defaulter or not, and you can also see here we have the option of the forecasting. Suppose if we want to create the model of prediction of the weather forecasting or the stock price prediction, we can use the forecasting option. But we will just simply go with the regression and the classification for our example. So let's create our data set. Since our data set is creating, it is the repository where we wrap up our data, where we just create a data set. And if we want to switch between the files, we can just simply go ahead and we do not have to create the data set again. Like if we see here, we have the data gate here. So reading about this, we have some minimum requirements whenever we want to build a solution using the AutoML, that you dataset has to be some inputs with the targets and the features. The dataset columns can be of any categorical or the numerical. We will do the transformation accordingly. Your dataset should have the minimum at least 1,000 rows, because the Vertex AI or the AutoML requires at least 1,000 rows to train your model. Before below the that count, it won't consider it for training a model. It will cause an failure. So it has the maximum capacity of how much data it can handle. Like you can see a data set size of 100 GBs, columns of thousands, rows of 100 million. That is huge amount. So we just simply click on next. Like we also have the option of what kind, from the which source we want to fetch our data. Like we have the option of BigQuery, CSV, and going to the next page, we have the option like how we want to split our data. Well, Vertex AI automatically splits our data into 80% of the training part and the testing part, and then there it has also the cross validation part, where you can select if we want to customize it, but it selects by default. So let's quickly select our CSV file here. So as you can see, we have selected a CSV file of the credit card data, which contains our features and the target. So we have the option of the select a cloud storage path. In cloud storage path, we define our bucket where we want to store our data set. So we won't be losing it, or we can store multiple data sets by creating that particular bucket. Like we have already created the demo bucket, but for knowledge, let's consider if you want to name our bucket like this. You can simply name it. You just simply click on continue. You have the reasons of the multi-region, dual region, and the region. In multi-region, you get the low latency, where you get the profit of interacting with your ML model, where it responses fastly in the multiple regions. In the dual regions, you get the dual regions, but it has the higher latency, so the response time will be a little bit late in comparison to the multi-region. In the region, we also get the low latency here. The response time will be faster here in the single region. So continuing with the that, like if we create continue, we have the option of the other options, like set standard of the data, choose what kind of data we have. So we will just simply go with the standard option and click on continue, where we have the option of the uniform and the fine data. In uniform, we can assign the access where we want, to whom we want to give the access to our data sets. And in the fine grade, we can simply individually assign the permissions to a data set, so no, it is not available publicly. And we click on the create, but I won't be creating the bucket because we have already did that. And in the demo bucket, we have to select our demo bucket. Like we can see here, a data set is already present here. We simply have to click select. So once you select your bucket, you can see it is popped up with the green tick. So it is now okay. Let's click on the continue. Since it is creating and making our data into a single wrapper, where we can modify it further according to our need if we want to do the trials on the different data sets. So as we can see here, it has successfully created a data set where we can see what kind of features our data has. Like we can see here, we have the feature name, bill amount 1, 2, defaulter, limit balance, pay 0, and there are many more. So we get all the features representation in the Vertex AI AutoML UI. And we also have the option of creating the statistics, where we get the count here. If we click on the generate statistics button, we will get the count of the how many distinct values are present in a data set, how many null values are there, and what are their relation among each other. Since we have already created a data set, let's move to how we train our data set. So click on the training portion, and we simply click on the create button. Now here we are creating the pipeline of our training model. So here we have, like we can see here, it has already fetched the latest created data set by its own, and it has already identified what kind of problem we are going to create a solution for. Like we have discussed, it is a classification problem, so it is selected by its own. So that's how it is using most of our tasks. So let's click on continue. Now we name here what we want to name our pipeline. We want to do some mention some description here, what kind of problem we want to describe it here, we can simply mention it here. In the target column, we mention our target column where it has the labels a person is a defaulter or not in the representation of either it is a true, false, 0, 1, yes, no, anything can be there. So we have chosen the target column here, and let's click on continue. While in we have created the training pipeline, half of it. So we have the option of generating the statistics again, and we also have the option of finding out the correlation. If we click on the generate statistics again, you will get in some minimum time like 15 to 20 minutes, you will get the correlation between the feature, how they are related with the target in the numerical terms. And if you want to also exclude some of the feature or include some of the feature, you have the option of the include in the training part or exclude from the training part. If you do not want that particular feature that you seem it is not proper in your data set, that you can exclude it or include it according to your need. You have the option of the transformation. Suppose we have the categorical data or the numerical data and we want to do some transformation there, we can choose any of this option like automatic, categorical, text, numeric, timestamp, but simply we will go with the automatic. So Vertex AI will automatically do the transformation of that features, and we do not have to do it manually. Like here it is again using our most of the task. In the weight column section, as we can see here, we assign a feature with some weightage. Suppose if we have done some analysis on our data set and we find out that our data, some of our feature are having the most important role, and we want to assign the most of the weightage to that particular feature, you can choose any of the features that you have visualized or analyzed accordingly. And still I am not going with that particular weightage column. So Vertex AI will also identify, AutoML will also identify that for us and do the training part. And the optimization object, where our motive is to reduce the errors in training phase. And we have the matrices like AUC, ROC, area under the curve, log loss, where the objective is to reduce it to the minimum, AUC, PRC. So these are all the error matrices here. So I will just go with the default and click on continue. So we have the budget hour, where we have to select our budget hour depending upon how much rows are present in a data set. Because if you have some more count in a data set like above 10,000 or millions, so it depends how much computation time it will take. So we have to choose accordingly, that if we select less budget hours and our data set is large, that it might run out of time. In early stopping, it has the feature where our model is sufficiently trained and it is not improving any further. So it will automatically stop the training phase, and it will save our computation in terms of cost and in terms of hardware also. So that's also a good feature of the Vertex AI AutoML. So I will just simply click on mention one budget hour here, which is node R, and we have to click on the start training button. Since Vertex AI AutoML takes a little bit time in training our model, so we have already trained that model for a demo. Like we can see here, credit card defaulter demo is already finished with the training. So our pipeline is ready. Let's click on it. Like we can see here, it is loading. It takes a little bit time, but it has been sufficiently proven very effective in creating models. Like we have the option, like we have discussed in the precision and the recall error matrix and the ROC curve. We can see here F1 is collection Skriti discussed earlier, precision, recall. We have the confusion matrix here. We can see the how it is identifying between the two classes of a person, it is a defaulter or not. Like we can see this, if we increase the threshold value here, we can see it is increasing the ratios of the percentage. So these are all there. We get the feature importance, which feature is playing the most important part in our training phase. So as we can see here, page 0 has the most important role in a data set, which is impacting our output, and other features are also impacting, but they are aligned in a descending order, like we can see here already. So once we click on the deploy and test, we get the option of deploying a model to an endpoint. Once you hit the deploy to an endpoint, we get the option of mentioning our endpoint. Suppose we also name it credit card endpoint here. And let's go with the standard settings. So let's click on continue. Now, as we discussed, it has the configuration option of how to handle the instances of data. It has the traffic split. It is the computing node hours, like we can see here. I have discussed about the machine, virtual machine it provides to us, like we can see here. It has the machine configuration that we can choose according to our model. So I will still let it be default. We can enable our loggers, and we can enable this feature if we want to do the prediction and analyze how our model is giving the accuracy, and we can do that. And let's click on continue. While you click on continue, it has the like we can see monitoring jobs name here. We are just simple settings we can see here, sampling rate and all. Let's click on continue again. So when you go into the next field, it asks for the trading data location again. That is, it is asking again, suppose if your model is predicting in a real time and there is some kind of skewness that comes into the result. So it will identify how our model was performing on the training data and how it is performing on the real data. So it will identify between the how they are varying from each other. So continue with the target column, where we again manually mention here our target column. As we already know, it was the defaulter, so we have mentioned it here. So now we have the option of the deploy. Now once we deploy a model, it will start the deployment phase. It takes a little bit time to deploy a model, like 10 to 15 minutes to create its endpoint. So we have already created that particular endpoint here, so we won't be doing it. Like you can see, our model is successfully already deployed and it is showing the status of active. And like I've discussed, we can integrate this particular model in our application using its APIs. Like if we see here, now we have the option of the Google Cloud SDK. We simply have to do the authentication of the SDK. We create the JSON format if using the REST API where we give our inputs. We have the endpoints name here, project ID. We can see also here. And if we want to simply use it with the Python, you can simply just go ahead with the syntaxes and implement in this your application. So let's continue. Like now we are not integrating it, so I will just simply go with the prediction phase. Now we can see here it has already mentioned some inputs here, like we have in that data sets some limit balance, pay 0, pay 2. It has some values already settled in it that are fetched from the data set. And if we click on the predict button, it will do the computation and give us a prediction. So let's see what kind of prediction it gives. So it has identified that a zero label which was false, it is representing that a person was not defaulter. These were the values of a person related to its account that was a not defaulter, and it is giving us the accuracy of the 92%, and which means it is good. That is identify person is not a defaulter. So if we switch to the person that was a defaulter, and now we can see it is not giving the confidence score here, it is just giving 7%, which is assuring that a person is not a defaulter. So, and we also have seen, we can see here, it is the baseline prediction value. Suppose if we create a new model and we want to do the accuracy, so it is a basic minimum requirement that next model we have created, it has to at least exceed this score, because it has created its baseline. The model that we will be creating next, it should exceed this particular score, otherwise it won't be considered as a good model or performing or a good performance model, so it won't be effective. So our main objective is that whenever we create a new model, that should exceed the baseline score. So these were all the features of the Vertex AI that we have discussed in a few features here, like we can see, and we can create our ML models using this particular Vertex AI. So this was all about this Vertex AI. So any Q&A if you guys any want to ask.
It was a very informative session. Thanks, Aman. Thanks, Sanskriti.
Okay, thank you, Pallav.
Thank you so much.
Okay, thanks guys. It was really interesting session on AutoML. And yes, definitely we could also know about how a non-ML expert can also use some of the ML modeling part just by clicking few buttons. So that is great.
Yeah. Thanks, Pranav.
Thanks, Rama.
This was your first session, right? First knowledge session.
Yes.
Yeah, Bhavin.
Yes, okay.
Good job, guys.
Thank you, Bhavin.
Thank you so much.
Hi, Aman. Hi, Sanskriti. So, though everyone has praised you, so indeed it was your first attempt and you guys have delivered so well. Thank you again. And as of now, people are not having any such queries. So maybe they can later reach out to you if they be having any queries. We can wrap it up from here. Okay. Thank you everyone for joining with us.